Every structure you will ever design, a building, a highway, an earth dam, finally rests on one thing: soil. But have you ever stopped to ask, where did this soil come from? Once, all of it was solid rock. In today's class, we will learn how soil is born and the different types of soil every civil engineer must recognize. It is an easy chapter, and in GATE, ESE, and SSC junior engineer exams, examiners love it. So let's pick up these easy marks together. First, what exactly is soil? To a farmer, soil is the top layer that grows crops. To a geologist, it is loose material sitting above bedrock, but to the civil engineer, the definition is sharper. Soil is the uncemented aggregate of mineral grains and decayed organic matter produced by the weathering of solid rock. That one word, weathering, is the key to this whole chapter. And the subject we study was named soil mechanics by Carl Terzaghi, the father of the field, back in 1948. Here is a teaser to hold on to. Depending on how it forms, soil ends up either cohesionless like sand and gravel or cohesive like clay. Soil is born through a continuous loop that geologists call the geologic cycle. It has four stages going round and round: weathering, transportation, deposition, and upheaval, and then weathering begins all over again. Rock breaks down into soil. The soil is carried away, dropped somewhere, and buried, and over geological time it is uplifted and exposed once more, so the weathering starts afresh. Write these four words down. Examiners ask them directly. The most important stage for us is the first one, weathering. And weathering happens in two completely different ways. First, physical or mechanical weathering. This is the physical breaking of rock into smaller and smaller pieces with no change in its chemistry. The agents are daily temperature changes and the splitting action of flowing water, ice, wind, plant roots, and even burrowing animals. This gives us cohesionless soils, gravels, and sands. Second, chemical weathering. Here, the rock minerals are decomposed into entirely new clay minerals, and this gives us cohesive clayey soils. So remember this golden line: physical weathering gives cohesionless soil, chemical weathering gives cohesive soil. Once the soil is formed, the next question is, did it stay where it was born or did it travel? Residual soils stay in place right on top of their parent rock. Because they have not moved, they are usually relatively shallow. In India, our laterite and our black cotton soil are classic residual soils. Transported soils, on the other hand, are picked up, carried away, and redeposited far from their origin. These deposits can be very deep. Transported soils are named after the agency that carried them. There are four agencies: water, ice, wind, and gravity. Water gives us alluvial, marine, and lacustrine soils. A glacier gives glacial drift, also called till, and unsorted, unstratified jumble. Wind gives aeolian deposits, and the most important one is loess, which is wind-blown silt. Gravity gives colluvial soils like the talus you see heaped at the foot of a slope, and the buildup of rotting organic matter gives cumulose soils, peat, and muck. Quick hooks to memorize: alluvial means river, loess means wind, talus means gravity, and till means glacier. Now, a quick tour of the special soils that India's exams love. Black cotton soil, also called Riga, is rich in a clay mineral called montmorillonite. So it swells when wet and cracks when dry, making it a nightmare for foundations. Laterite is formed by intense leaching in hot, humid climates, which washes out the silica and leaves behind red iron and aluminium oxides. Bentonite is decomposed volcanic ash, almost pure montmorillonite, and it swells enormously. That is why it is used as drilling mud. And remember, the clay minerals sit on a ladder. Kaolinite barely swells, illite is in the middle, and montmorillonite swells the most. Let's lock it in with 5 quick one-liners. Try to answer before I do. 1. Loess is transported by wind. 2. A talus deposit is formed by gravity. 3. Soil formed by chemical weathering is generally cohesive or clayey. 4. The dominant clay mineral in black cotton soil is montmorillonite. 5. Till or boulder clay is deposited by a glacier. If you got 4 out of 5, you have already cleared this chapter. So, in one breath, soil is weathered rock formed through the geologic cycle, weathering, transportation, deposition, upheaval. Physical weathering gives cohesionless soil, chemical weathering gives cohesive soil. Soils are either residual, staying in place, or transported, named after the agency that carried them. And India's special soils, black cotton, laterite, and bentonite, are the exam's favorite traps. That's the whole first chapter of soil mechanics sorted. Now, this subject is a complete package. Along with this lecture, you also get a free practice paper as a PDF and a full solution video where we crack every question with explanations. And here is the best part, every single day we release a brand new subject. So, tomorrow, get ready for a new one, Introduction to Solid Mechanics. If this helped you, hit subscribe and tap the bell so you never miss a day. All the free notes and PDFs are waiting on our Telegram. Learn Civil easy, practice hard, and I will see you tomorrow. Take care.